Okay, so the question says, for the circuit below, what is the value of the current flowing due to the 6-volt source? So, in order for us to solve this problem, there are a few things that we have to look at. The first thing we have to look at is the type of components that we have in the circuit. So the question mentioned a 6-volt source. So this is our 6-volt source which the question told us about. And then we have some other components. We have 3 resistors. So we can label our 3 resistors. We can call this one R1. We can call this one R2. And then we can call this one R3. So we have 3 resistors and also a diode. Let's call this one D1, which stands for diode 1. So the first thing we look at is the type of components. And again, as we mentioned, we have a 6-volt source. We have 3 resistors and a diode connected in this circuit. So we have our 4 components and they're connected in a series parallel configuration. So that's 2 things we know about our circuit. We have some resistors, 3 resistors, a diode with a 6-volt source, and they're connected in a series parallel configuration. So the question wants us to find the current flowing due to that 6-volt source. So to find the current flowing, we can use our Ohm's law equation. So to find current, we can use Ohm's law. Right, and what Ohm's law says is that V, the formula for Ohm's law is that V is equal to I times R, in which V is the voltage drop, I is the current, R is the resistance of the resistor. So we are given that we have a 6-volt source, so we are given V. We want to find I, but we don't know the resistance of the circuit. So the first thing we have to do then is to find the resistance of the circuit. But because of the configuration of the components in the circuit, we have to be very careful of how we consider the circuit here. So this is our source. So this is our 6-volt source right here. Right, on this side is considered to be the positive side, and this side considered to be the negative side. So we have our positive side because this side is the longer side. So whenever we draw our cells, the longer side is always positive and the shorter side is always negative. Now, the reason why I mentioned that is because we're going to look at a polar sensitive device. In this case is our diode, right? So let me write diode. Now a diode is very sensitive in terms of how it is connected in a circuit, right? The only way current will flow through a diode is if it's in a forward bias configuration. And what we mean by a forward bias configuration is we must have a positive, the positive terminal of the diode So let me just write that. So for the diode, it must be connected in a forward bias for current to flow through a diode. So, and again, as I said, for a forward bias, we must have the positive terminal being connected to the positive side of the circuit and the negative terminal being connected to the negative side of the terminal. Now, to identify the terminals of a diode, this side here is considered to be the negative side and this side here to be the positive side. So it is assumed that current will flow from the positive and out the negative. So we must connect our negative side of the diode to the negative side of the battery and the positive side of the circuit must be connected to the positive side of the diode. So in this case, we're seeing that the positive side of our 6-volt source is connected to the negative side of the diode. So in that case, the diode is connected in a reversed bias. So right now it's connected in a reverse bias. Reversed. So once we have a reverse bias, then we get no current flow. Okay, so once we've just established that the diode is connected in a reverse bias, so what does that mean for our circuit now? So it means then for our circuit, whenever we have a current flow and the current comes to this junction, right, what will happen is that instead of the current going this way through the diode, all of the current will actually go right here, because this is in a reverse bias configuration, so it will act as an open right here. So there will be no current flow in this direction. All the current will flow in this direction. So we'll have all the current going this way. So if we have established that, we can find the resistance of our circuit, knowing how the current will flow through the circuit. So what I will do right now is redraw the circuit and take into consideration right here is acting effectively as an open in the circuit. So all the current will flow in this direction. So I can redraw my circuit. So that's my 6-volt source. Again, we won't have this branch of the circuit because we're going to ignore that because it's merely an open in the circuit. So I'll have my R2 resistor, and then I will have R3 resistor. So this effectively is my circuit. Again, this is 6 volts. This is 2 kilo ohms. And this is 1 kilo ohms. Now, to find resistance in series, we simply take the sum of each individual resistor. So we can say that RT, which stands for total resistance, is equal to this resistor, which is R2 and R3. So it's equal to R2 plus R3. And again, there is no current flow through R1, so we can ignore that when we're finding our total resistance, because that resistor will offer no resistance to the circuit. So we can write R2 again is 2 kilo ohms and R3 is 1 kilo ohms, 1 kilo ohm. So if we take the sum of that, we get that R2 plus R3 is equal to 3 kilo ohms. Now the question initially wanted us to find the current flowing due to the 6-volt source, right? So we're going to employ our Ohm's law equation, right? So rewriting Ohm's law. So taking Ohm's law equation, we can write V is equal to I times R. We know our voltage, we know the resistance, which is what we just find right here. Now we can find I. So when we rearrange our formula to make I the subject, we get I is equal to V upon R. Right? So our voltage again is 6 volts, and our resistance, which we just find right here, is 3 kilo ohms. So it therefore means that if we were to divide 6 by 3, we would get 2 milliamperes, or 0.002 amperes. So this effectively is the current flowing due to the 6 volts source. Alright, so again, this was Junior Roberts coming to you with realjuniorroberts.com. If you found this video helpful, please hit the like button, share your comments below. If you think this might help someone, consider sharing it to their friends, subscribe, and hit the bell notification to get updates on further videos as soon as they become available. Thank you for watching.